Okay, so what we were doing last week was actually the sine rule. So now we'll be continuing on actually the application of sine rule, which is the last thing on sine rule based on the textbook, the hardest question. So I'll just guide how we do actually this question a bit, and then we will go on to the ambiguous case. Okay, Aldeep. Okay, so now we see there is a tower like this, which is slanting, and then it's in the shape of a triangle you see here. So this is the tower, and then they said that the tower has an incline by 7 degrees from the vertical line. So basically the vertical line is this one, straight down like this, and at a distance of 100 meters from the side of the tower, the angle of elevation is 30.5. So the 100-meter will come here because this is the side of the tower. And then they asked to estimate the height xy, means this height over here. So this is what we are finding. And then now we have to find where is the 90 degree actually in this question. So when you see here, we can find out that this whole thing is 90 degrees from this vertical line, because vertical line to horizontal is always 90 degrees. And then they said it's inclined by 7 degrees, means it's like bent 7 degrees. Like this means if this is the vertical line, this is the inclined surface lah, and the angle in between these two is 7 degrees. So that's how we are finding here. So this angle here from the inclined line to the horizontal will be 83. Generally, it should be lower than 90 because it's less than a right angle like this. So this is the 83, and the inclined one is 7. So they asked to estimate the height of basically the incline, how long is the incline plane there. So what we are going to do now is, we already found here is 83. There is a triangle here also. This triangle over here. So now we want to find this angle here so that we can use the info given here, which is 100 meter. So if you want to find the angle, we will take angle will be 180 degrees minus 83 degrees minus 30.5 degrees. So what we get actually is 180 minus 83 minus 30.5 is 66.5. So the angle here is 66.5. This angle over here. And then we are going to apply the sine rule. So what sine rule says is like this. A over sine A is equal to B over sine B. So now we have to find the opposite pairs in this diagram. So the opposite pairs that you can see here is 100 meters is opposite to the angle 66.5. And what we want to find now is the xy, right? So we will opposite to the angle given here, which is 30.5 in the question. This one is given. Don't have to find. Don't have to find. This also is given. So now we're going to apply the sine rule. So basically we'll take 100 meter over sine 66.5, which is the opposite angle, equals to the xy, that is the height of the tower, over sine 30.5. So xy, let's go other side. Xy will be 100 meter times sine 30.5 over sine 66.5. So what we are basically doing here is the cross multiplication. No? The longest step will be xy times sine 66.5 equals to 100 times sine 30.5. So that's how I shift the xy to this side. I mean, I shift this side 66.5 down here, means it comes divide. So what we will get is xy is equal to 100 times sine 30.5 over sine 66.5. We will get xy length as 55.34 meter. 344 meter. So basically, you can put it up to 3 decimal place or 5 significant figures based on the answer given. So that's how we apply the sine rule to actually find this whole thing. This is the sine rule. So this is the formula you will find in number 22 of your formula sheet. So number 22 is your number 22 to 24 is basically the solution of triangles formula. The whole thing is solution of triangles. So this is the application. So actually it's not that hard also in any way, because the whole thing is basically playing on this sine rule only. So sine rule, you have to master how you relate the lines and angles. That's the most important thing here. It's about lines and angles. So then we can already sub the values, and then make sure you know how to press your calculator. Do it separately. Don't. I think you can do one shot in this case. Also, you will get the answer. Yeah, you also get your answer. So this is how we do it. One shot. So this is the hardest question that can come for sine rule based on the textbook. So next, this is the end. Next, we will be going to ambiguous case. So ambiguous case is the next subtopic. Is actually an application of sine rule. We can only apply ambiguous case in sine rule. So let's see how it is. So sine rule, ambiguous case. So now we have to analyze this word ambiguous case to understand what they're actually trying to say. So generally this word you can break it down into the word. We see this word ambiguous first. So we have to see what is the definition of it. So ambiguous means open to more than one interpretation. Or in other words, not having one obvious meaning. And another way to explain it is also not clear or decided. So this is coming from the English definition, these two. In BS, it will be something like tak menentu lah, so I can direct translate. It means it's not definite, it's indefinite. So that's how they came. Case means we want to study. We heard of case study. So we want to study this phenomenon of ambiguity. So they come up with the ambiguous case. So now we will analyze this word mathematically. So ambiguous case comes from the word ambiguity, which actually means inexactness, or you can say not precise, or the quality of being open to more than one interpretation. Means it's like you can say it's debatable, this thing. There's no fixed answer on it. That's why you have many possibilities of triangles that you can form from this ambiguous case, which can go from 0 triangles up to 2 triangles. So basically here you are considering possibilities to solve this question. So you will see this question usually appearing in your section C, of course, because it's in the chapter 9 of Form 4. Part A will be a simple question, 2 marks. Part B will be a simple question, 2 marks. And then part C, usually in part C, they will ask you, they will break it down to C1, C2. First, they will give you certain conditions. Let's say let JK equals J prime K, angle B prime C equals BC. So then with this condition, they'll ask you to construct a different triangle that can be formed. So this is a common one which you can see in this chapter, basically this first question. And then the second one, they will ask you probably after you construct this, hence find, let's say, angle B prime A, B, C prime A. So this is how the question can go. So they will give you certain assumptions you have to consider, and then you construct the triangle, and then after that you find a specific angle they mentioned there. So that might basically carry you maybe, let's say, if I add one more mark here, 5 marks, then constructing maybe 2 marks, finding the angle 2 marks. And then one more mark can be up from here somewhere. They can plus 1 here. So this is how they can come up with a complete question on solution of triangle. Also, one more thing they can ask you is the area of triangle. They'll ask you the area of one triangle. That one will be another 2 marks. That's how they complete the whole question. So they test you sine rule, cosine rule, and area formula all in one question here. So this is the starting of the ambiguous case. So in cosine rule, you won't see this, only in sine rule. So it's how you construct the triangle. Example, I have one example here. So example, you just think of the concept of isosceles triangles. This is what they are usually playing when they ask you to construct a triangle. I mean, a different triangle from the conditions given. So usually they will test you on this. They will be playing on isosceles triangle. So this is actually called segitiga, kaki sama, and BM. So the basic triangle looks like this, A, B, C. Means this side is same as this side. This angle is same as this angle. So isosceles triangles, this is where you apply your sine rule. So this will be found in your sine rule, isosceles triangles. So yeah, nothing much. This is how you must know how to form this. That's the only thing. And then you can find the angles easily, because from here itself, if you have this angle, you can already find this angle. Then you want to find this angle, you just take 180 minus the 2 theta times this angle times by 2. So So this is how you find your angle L. So in this case, they have this kind of triangle. Something it looks like this. So like this. Uh, then it comes down here slightly and a flat surface like this. So what you need to do is actually think of how you can form another triangle in this without learning the conditions for ambiguous case. If you just see directly, here is one triangle. This is only one triangle. So you must think how can you form another triangle from this. So if you see here is slightly longer from the center, right? This is the center. I mean, where these both lines intersect. So that's the center. So you see, if we can put this line over here and make this angle equal to this angle. This angle is also equal to this angle. Let's say theta 1 and theta 2. So this is how you form an isosceles triangle actually. So basically all maybe 90% of the questions you have to use the isosceles triangle over here. So yeah, this is how they do it. And then the side labeling is like this. On top here is C, here is A, and then here is B. So here is B prime. B1. The label here is B1. So yeah, because here you're actually projecting the thing on the B line, right? BC line. So here, since they already label A, so here you have to use as B, because here they use as B1. So here you put as B1 when you touch the surface. So this is how you differentiate between this B and this B, because it's two different things in the end. So this is the ambiguous case. Wait. So what you observe here is your observation. So this is basically relating to the ambiguous case, no? Two different triangles can be constructed. Two different triangles can be constructed by using non-included angle. So this I will explain later in the slides what is actually a non-included angle. By using non-included angle and length of two sides. So this is the minimum requirement for you to satisfy the ambiguous case of triangle in sine rule. So the two things are again non-included angle and length of two sides. Must have two sides. One cannot. So next thing, these are the next thing is about the three triangles that you can form from here. So this is the theory part. And then one more part of the theory is this one. These conditions you don't have to memorize, you just have to know how to apply it in the question, because they won't ask you what are the conditions for ambiguous case. You have to know how to see it and construct a different triangle only. That is what they'll be testing on. So, okay, this one. So we have three triangles here. They did it quite well here in the textbook. They gave in a table. So the table goes like this. So three columns. These three columns, three rows actually represent the three possibilities of triangles you can form. Three possible triangles. So the first column is no triangle exists. There can be a situation where you can't actually form a triangle also because of the side length, the length of side. And then the second condition, a second possibility is one triangle exists. And the third condition, second triangle exists. Second triangle exists means two triangles can be formed, two in one large triangle, two small in one large. This is what second triangle means. So how they draw it is something like this. There's a triangle here and then a side here. So basically they removed one of the side, which is BC. So it's A here, B here, C here. This is the height of the triangle because the triangle is like this, something like this. I can't form it here. Triangle is something like this. So the height is basically from here to here. This is the height. So they took off one side, which is the BC, and then you see this line they put as A, quite short one, they put as A. So this is the condition where A is less than the H. So you can see clearly here, this is the height, this is the length of A. So definitely look, A is shorter than H in terms of distance. So that's why we can't form completely a triangle. Because when you form like this, only is considered one triangle. This is not a triangle yet. So that's why they call it no triangle. And then the next one, when one triangle exists, it will look like this. Like this, like this, like this. So here, CAB follow the same arrangement. So we will get A is equal to H. So this is the height of the triangle. Why they label it as A is because it's between the alphabet of B and C. So the side length of automatically will come a small a. So that's why it's A equals H. And then between B and A is called as C. Here also is C. And then this is the thing. This is the condition where A equals to H. And then another one, the triangle can look like this. A sleeping triangle or something like that. So A, B, C. And then here is C, here is A. In this case, A can be actually more than C based on the length. More than or equal to. A is more than or equal to C. Yeah, because you see in this case, it's slightly same, this length and this length. But compared to here, A is more than C definitely. Here, there's a chance quite close to be equal, but not equal exactly. There's a chance only. So this is how they form one triangle here. Either this or this. And then when the second triangle exists, it will look like this. A, B, C. And then this is the C, this is the A. And this is the height, obviously. Right angle means it's perpendicular to the line AC. The height will always be perpendicular to its base. So H is less than A, is less than C. So how they form this thing is, you see, the height is definitely shorter than the A because A is hypotenuse. And A is also less than C. Because this triangle, if you see correctly, it's actually slightly larger. So this line will come longer than A. It looks like this. It depends on the angle joining the two lines. And there's another triangle like this. It looks like this. And then they put the height outside the triangle. So height A, B, C. This is A. This is C. So you can see clearly from here, height is less than A, obviously. And A is also less than C because C is slanting further compared to A. So this is how you form one one triangle and also two triangles. So the conditions Here don't have space again. Let's do again. So the condition stated, this is where the theory comes in. How to determine whether an ambiguous case exists or not. This is the last page for the theory. So let's start. Okay, so the topic is determining the existence and solving triangles involving ambiguous cases. Okay, we can break this into two parts. Determining the existence is what we are doing so far. This is the first part. We haven't entered yet solving triangles involving ambiguous cases. This is the second part, application. So now so far the first part only. So now it's the theory. Ambiguous case exists if. So one condition, two conditions. So you need to check these two things in a given triangle before you can say that an ambiguous case exists or not. So length of two sides. So must be 2. Make sure it's 2. So two sides. Randomly, they give here A and C. It can be B also. And a non-included angle. Non-included angle. Angle A, which is acute. So the name of the angle is angle A. And this is the important part. It has to be, the non-included angle has to be an acute angle. So what's an acute angle? It's actually an angle like this. This is right angle. So if I draw like this small angle here, let's say I put 45. So anything 0 less than x less than 90 is an acute angle. So 45 degrees is an acute angle. X is any value of the angle. Okay, so this is how we first condition to satisfy. And the second one is the side opposite to non-included angle. Non-included angle, they gave it as A, is shorter than side C. Means this angle, let's say a side opposite to a non-included angle means something like sine rule. We relate opposite sides and lengths. So side opposite to non-included angle must be shorter than the side C. But also there's another condition. But it is longer than the height of the triangle. So these are the two conditions. Actually, three. They simplified it into two. Length of two sides A and C. This is the first condition. Length of two sides and a non-included angle. Second thing, and also must be acute. Third thing for the first part. And then the second part is side opposite to non-included angle. Opposite to non-included angle, fourth condition. Shorter than side C, fifth condition. longer than height of triangle, 6 condition. So totally in 2 points, you have 6 conditions to satisfy when you want to determine whether it's an ambiguous case or not. So now we'll go through some slides. It'll be easier to understand through exercise. Wait, let me see first. We shall try some textbook examples first. So yeah, we try the textbook example first because usually questions in textbook also has they can manipulate the question by changing the values and give it in the same form. So don't look down on textbook questions also. So they can be tested also in the exam. So we go to textbook instead of the random questions they give. So now we are trying to apply all this theory that we have learned into practice. So first question is determine whether ambiguous case exists or not. Explain your answer. So basically when they say explain your answer is how you want to explain. So how to explain will actually come from the conditions that satisfy. So I explain based on the 2 points that I shared earlier. You have to satisfy those 2 conditions. No? So your explanation basically is you tell back those conditions, but you must change the angles and lengths. Because question will give A, B, C, or what, they can change it to PQR like this. So P, Q, and R. PR they give 7 cm, QR 4 cm, and then they ask you to find whether it has ambiguous case or not. So let's see. Here is 30 degrees. Angle RPQ is 30 degrees. So how we determine whether it's ambiguous case or not, we see. Can we form another triangle here? So you can see, right? There's a possibility we can form like this. Isosceles 4 cm, because this side is a bit away from the height of the triangle, which is this. This is the height of the triangle. So these 2 triangles are equal. These 2. So ambiguous case exists. So why ambiguous case exists? It's actually in triangle PQR, of course, the whole triangle. Not focusing on specific triangle generally. So the reason is, so we understand the reason together, non-included angle. So this is the non-included angle. Usually the angle they give in the diagram or the question is actually telling you the hint that this is the non-included angle. The non-included angle is actually the angle which is here at the side here, and it's acute. You see, it's satisfied. 30 degrees is between 0 and 90, right? So it's an acute angle, and it also satisfies that condition. So they said non-included angle, which is angle QPR, is 30 degrees. Or you can say non-included angle is an acute angle, also fine, which brings out the same meaning. And side RQ is shorter than side PR. This is the condition that we said earlier. It has to be shorter than side PR. Shorter than side PR, but longer than the height of the triangle. Means it's the way they phrase it is side RQ is longer than the height of the triangle, obviously, because if you draw a height here and then here is 90 degrees, RQ is automatically becomes hypotenuse. And what we learned from hypotenuse is Pythagoras theorem. C squared equals A squared plus B squared. So it's squaring up the length of these two sides. So definitely here we'll get a larger value automatically. Like 5 square is 3 square plus 4 square. So the 5 is actually the RQ length, longer than 3 and 4. So that's why they say it's longer than the height of the triangle. So this is the first example, how you actually explain your answer on this. This one is in the case where it exists. They can also give a question where it doesn't exist so that they see how you actually explain your answer. So let's see the case where an ambiguous triangle won't exist. Like this, like this, like this. Okay, so they gave you here is PRQ, and then angle RPQ is 40 acute. This one is 80, still acute. And this one we can find 180 minus 40 minus 80 is 60. So this one also is acute. So this we will call as an acute angle triangle. Or another name is, we can see, is a scalene triangle. Means not all sides are not same length. You can see from the diagram directly, so it doesn't look like all are same length. So they gave here the length of 21 cm, and then the length here is 17 cm. See, 21 cm. Here's 21, here's 17. And then they ask you to determine whether it exists or not. So we can see here directly. When you see two angles directly, you will know it cannot be an ambiguous case because angles of two sides are given already. Means the angle that forms this side, this angle bounds this length here, and then this angle bounds this length here. Means two sides, but angles of two sides have been given. So that's the reason. So how they write this? Ambiguous case does not exist. Then you have to give your reason, because the angles of two sides are given. So we recap the condition just now. They said ambiguous case can exist only if length of two sides and a non-included angle. So here you see there are already two angles. So we cannot say it's ambiguous. Only one angle must be given and it must be acute. In this case, both angles are given, two angles, and both also are acute. So definitely out. It doesn't satisfy. First condition, if it doesn't satisfy, automatically you can reject already. So it must satisfy both conditions. Then only you can say ambiguous case will exist. This is the key. So these are the two examples of ambiguous case. So now we determine already. So now we are going to the calculation part. This is the part where the exam asks. This one is just to understand overall on ambiguous case. Here they'll ask you to sketch the triangles. Okay. Okay, so here there is one triangle only in the triangle ABC. There's a triangle ABC. Angle BAC is 40. AB is 20 cm. BC is 14 cm. So they say calculate possible values. So here you will be having two answers of angle C and angle B. Means each angle you will have two possible answers. Angle C, there is two answers. Angle B, there is two answers. So total up, in total you will have four answers. Four answers. So basically it's 4 marks. Minimum you will get 4 marks already after doing this question. So this is first thing is determine whether the ambiguous case exists. So step 1, they're describing the steps how to solve. Determine whether the ambiguous case will exist or not. So we draw the triangle out first to analyze it. So let's draw it together. Like this, like this, like this. This side is longer than this side because here is A, here is B, here is C. So they said in the question, the info, remember when they give you info, fill in inside the diagram so that you know what you're having. BC is 14 cm, AB is 20 cm, and they said angle BAC. When they how to read angles and fill into the diagram is you see the middle letter of the angle. Middle letter of angle. So you see the middle letter here is A, right? Means A is 40 degrees. Don't care about the B and C. B, A, C. Stop at the middle, this the 40 degrees. So 40 is there. And then that's all the info they give. And then they ask you to calculate a district. So let's see. So here you can see, right? Only one angle given. One angle. And it's acute. Why? Because it is in between 0 degrees and 90 degrees. So that will ring a bell in your mind that ambiguous case has a chance. Because first condition has been satisfied already. And the side opposite to the non-included angle is shorter than the other side. 14 cm is shorter than 20 cm. And it's longer than the height, obviously, because this is the hypotenuse. So that both conditions satisfied already. Two satisfied conditions. So we can apply the ambiguous case rule. So let's see. They will find the height first. So where the other triangle you can construct is here. Draw it down here. And here you label C prime because here it touch C, right? So here when you project from B down to the base is C prime. C1 or C prime, anything is the same. As long as you show it different from the alphabet C. Okay, so we find the height. Height H. This to prove whether it's correct. They still want to prove. Although we already know, in fact, that the height will definitely be shorter than the length of this side. So how we find the height here is actually here. We use this angle here. If here height, right? Here is the triangle. This is the triangle. So this angle is opposite to the height. So height will come opposite. And this length over here is adjacent. So adjacent is here. And AB acts as the hypotenuse because the right angle over here. These two is right angle. Because on a straight line, the total angle must be 180 degrees. So we already found that. So how we find the height is we have opposite. We want to find the opposite, and we already have the hypotenuse. So opposite hypotenuse sine. That's the pairing. So how they work this out is sine 40 is the height, which is the opposite, over the 20 cm, which is the hypotenuse. So when you shift h is 20 sine 40. So this is how they get here direct. If you cannot see directly, don't show this working. Use this step to get this step, so that you don't make careless mistake. So 20 sine 40, get the height is 12.86 cm. 12.86, 856. Give to 3 decimal place, preferably. Okay, so now then they make conclusion. Since h is less than BC, h is less than BC, of course, because 12.856 is less than 14 and less than AB also, means BC is less than AB and